given some x of t, find all the w hat a terms and phase angles for L equals 0, 1, and 2. The first thing you need to do is you're going to create this table here. I'm going to show you how the table works, but go ahead and make sure that this is on your cheat sheet because you are going to need this. So the very, very first thing we need to do is we need to turn our x sub t into all positive cosines only. So to do that, the very first thing we have is 3. 3 can be left alone. It's our DC signal. It has no sine. It has no cosine. It gets left alone. Now, we need to look at our sign. Well, we have a negative sign. We need to convert that into a positive cosine. To do that, we need to add pi and subtract negative pi over 2. So in reality, I'm just adding a pi over 2 to our phase right there. So what I'll end up getting is, I'm going to scroll all the way down. I'm just going to rewrite this. So x of t equals 3 plus cosine should be 500 pi t and then I believe it's plus, plus pi over 3 plus pi over 2, and then our FSA, so our sample frequency, I believe was 300 hertz. 300 hertz. Okay. First thing we need to do is we need to add our phases together. To do that, I'm going to make a common denominator. So it's going to be 2 pi divided by 6 plus 3 pi divided by 6. So I'm going to get 5 pi divided by 6. So x of t equals 3 plus cosine 500 pi t plus 5 pi divided by 6. Now we need to convert this into x sub n. So x sub n equals 3 plus cosine 500 divided by our sample frequency, which was 300, pi n plus 5 pi divided by 6. So x of n equals 3 plus cosine of 5 pi divided by 3n plus 5 pi divided by 6. Perfect. This here is our w, like our original w hat, or normalized frequency. This here is our theta naught. So I'm going to go ahead and I'm going to fill in what I know. So I have 5 pi divided by 6, negative 5 pi divided by 6, because this is plus or minus. I forgot that part. And this is also plus or minus. So I'm going to get 5 pi divided by 6, negative 5 pi divided by 6, 5 pi divided by 6, negative 5 pi divided by 6. The next thing we need to do is fill in our normalized frequency into all these values here. I'll do that in green. That should be 5 pi divided by 3. So 5 pi divided by 3, negative 5 pi divided by 3, 5 pi divided by 3, negative 5 pi divided by 3, 5 pi divided by 3, negative 5 pi divided by 3. The next thing we do is we're going to start filling in all these values here. So L is 0, so these values are going to be 0. So 0, 0. Now's the next one. We have 2 pi. Now, I'm going to show you a little trick. Yes, you can just write this as 2 pi, but it's much better if we make common denominators because we're going to need to add these. So this is 6 pi divided by 3, negative 6 pi divided by 3, 6 pi divided by 3, negative 6 pi divided by 3. The next one's 4 pi, because 2 times 2 pi is 4 pi. We need a common denominator, so we're going to have 12 pi divided by 3, negative 12 pi divided by 3. 12 pi divided by 3, negative 12 pi divided by 3. The way now, I'm going to show you my little trick. I take these values here, and you just add them all the way down. You add them, and this is what you equal. Equal, equals, equal, equal, equals, 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 equals. So this one is going to be 5 pi divided by 3, negative 5 pi divided by 3. This one is 5 pi divided by 3 plus 6 pi divided by 3 is 11 pi divided by 3. It's going to be negative pi divided by 3. This is pi divided by 3, negative 11 pi divided by 3. Notice these are the same, but just the conjugate. That way you can double check yourself. Don't go and just do the top one and then fill it in for the bottom one. Use it as a way to check yourself and make sure you don't make any mistakes. Next one. 17 pi divided by 3, negative 8, 9, 10. So this would be 7, 8, 9, 10, 11, 12. Yep. 7 pi divided by 3. This is 7 pi divided by 3, negative 17 pi divided by 3. And this is your answer. This is your final answer. If it wants you to plot it, you go ahead and just plot these points. This is your W hat, and this is your phase attached to it. And then your amplitude is obviously just half of the amplitude here. So if you have any questions, please let me know. If you need me to graph it just in case, let me know. I'm more than happy to go over that and how to graph these kinds of problems. But just remember, step by step, first thing we do, convert your x sub t into your positive signs, so your positive cosines only. So to do that, to convert this to cosine, we subtract pi over 2. To convert this to a positive, we add a pi, and that's why we have pi over 2. We go ahead, divide the frequency by our sample frequency to get our normalized frequency original, and we have our phase original. We plug those values in, and look at how they alternate. They alternate. It's plus or minus. They alternate every time. They alternate every time. Notice this one here doesn't have 2. You can do 2 if you would like. There's just no point because for this one, they're going to be exactly the same. If you have any questions, leave them in the comments. I'm more than happy to answer them.